Hello everyone and welcome back to the channel. Problem number 436. Find right interval. So you are given an array of intervals where intervals of I equals start of I and end of I, and each start of I is unique. The right interval for an interval I is an interval j such that start of j is bigger than or equal the end of I, and start of j is minimized. Note that I may equal to j. We need to return an array of right intervals, indices for each interval of I. If no right interval exists for interval of I, then put -1 at i's index. Okay, so I would say the description of the problem is not that easy to understand. So let's try to describe the problem better so we can understand it. So imagine you have a list of tasks or events, okay? Like meetings or work shifts or personal appointments, and each task has a start time and end time. For example, we have a task that might have this and this, meaning it starts at 1 p.m. and ends at 5 p.m. And we might have another task that could have 6 and 8, 8 not 9. That means it starts at 6 p.m. and end at 8 p.m. Okay, your boss gives you a rule: no two tasks will ever start at the exact same time. This is quite important. Now, for each and every task in your original list, your goal is to find the right interval. What is a right interval for task? For example, this task. So let's let's take another example. Let me copy this because I guess I might need it. Okay, so let's pick one task. Let's call it task A, which will be intervals of I, which will have start A and end A. You need to find another task. Let's call it task B, okay, which will have intervals of J, which equals start of B and end of B. You need to find it that fits two conditions. First, it must start on or after task A finish. For example, if this task ends at 5 p.m., okay, task B should start at 5 p.m., 5:30, 6 p.m., etc. Task B cannot start at 4:30 p.m. because that's before task A finishes. Okay, among all tasks, number two, the other conditions with the among all tasks that fit condition one. Let's say that we find multiple tasks that fit condition ones. You must pick the one that starts the earliest to task A. So this means you want to find the task that starts the closest to when task A ends without starting too early. An example: if task A ends at 5 p.m., as we said, task B and you have task B starting at 5 p.m. as well. So start of B will equals it is 5 p.m. And we have task C starting at 6 p.m. That's okay. So, and we have task D start at 7 p.m., etc. And all of them satisfies the first condition. But task A or task B, sorry, task B starting at 5 p.m. is the one that starts the earliest among them. So task B would be the right intervals for task A, and that's it. And for each original task I, you need to put its right intervals, which is original position index, into a new list. If you find a task B that fits the rules for task A, you write down task B's original index. If you cannot find any task that fits the rules for task A. Then you write down -1 for task A spot in the result list. I hope my description, understanding the problem, was good, because right now we will start in the solution. Let me increase the text here. Let's make it 19. I guess this is better. Okay, so let's talk about the solution. I guess we need to create a variable called m, uh, which will equals intervals.length, because we will use intervals.length a lot in our solution. So let's put it in an easy variable. So step one, we will pair start time with their original indices. Basically, each element in the array that we're about to create, let's call the array, the create array, start point, start start point, start point, points with in indices will equal an empty array. Okay, so here we will pair start times with their original indices. Basically, each element in the start point with indices will be have start value and the original index. Okay, so what we're going to do, we create a for loop, let I equals 0, and I should always be less than n, and I plus plus, and yeah, and I would say start indices dot push. There's something, yeah, dot dot push. It will be, I'll push the intervals of I. Sorry, I need to put this in array also. And I will put the index. So I put the value and the index, because we will need this one. After that, after that, I need to sort the new array based on the start values in ascending order. This allows us to perform a binary search efficiently. So we will sort this dot sort, and it will be A, B, and I will sort it by the starting time. Oh, sorry, I forgot to do it, because I need start time, because each one here is an array. I guess, yeah, this is right. Yeah, this is right. A minus B, but should be also by the start. So A of 0 and B of 0. Okay, let me check. Yep. And I will create a variable called result, which will equals new array, and it will be by n, and I will fill them dot fill -1. Here we initialize the result array, which will store the right intervals indices. All elements are initially -1, as per problem requirements for no right intervals. Okay. And for step 3, I will iterate through each original interval. So for let I equal 0, I less than n, I plus plus. So here, this is a third step. We iterate through each original interval to find its right interval. For each original intervals, which is intervals of I, we will have the start of I and the end of I. So we will have first const current end, which will equals interval of I in the second position of index 1, And here, this is the endpoint of the current interval of I. I will create here let low. What's going on here? Let low equals. What's going on? Did I make something wrong and I don't know it? Okay, I got it. And here fun. Let low equals 0. Let high equals n minus 1. And let found right interval original original index will equals -1. Okay, so here we perform a binary search on start position with indices. Okay, to find the right interval, we are looking for the smallest start of j that is also less than or equal the current int. And this one found right interval original index stores the original index of the best candidate interval. I will create in it a while loop that will be let um, let low less than or equal high. Okay, and I will create mid. Let mid will equals low plus math dot floor high minus low divided by 2. We here get the mid. After that, const current candidate start value. So here we will try to get the start value and original index from the start array. So here we get the mid. So we need to get two important values. We will use start indices of mid of 0. Here we get the current candidate start value. After that, we will get the current candidate const current candidate original index, which will equals the same thing here, but it will be at the first index. Okay, so I will create an if statement here. So if current candidate start value, let's instead of writing, if current candidate start value is is bigger than, sorry, or equal current end. This is the first condition. So this candidate interval's start value meets the condition which say the start of j should be bigger than or equals end of I. It's a potential right interval. Since we want to minimize the start of j, we store this as our current best candidate. So we will update the found right interval original index to be the current candidate original index. And now we will try to find an even smaller start of j that still qualifies by searching in the left half of the start positions of the start points with indices array. So high will equals mid minus 1. And else Else, basically, this candidate interval's start value is too small. Basically, the current candidate start value is less than current of end. It does not qualify as right intervals. So the desired right intervals, if it exists, actually must be in the right half of the search space. So low will equals mid plus 1, and at the end of this loop, at the end of this loop, so okay, after the binary search here, for the current original interval I, we physically found right interval original index will hold the original index of its right interval, or minus 1 if no such interval was found. So result dot result of I will equals the found right interval index, and after that we return the results. Let's try to run it and see if it works or not. It didn't work. Why? uh, I plus plus. What's going on? uh, I plus plus, and here. Okay, it did work. Submit. Aha, it did work. I would say this problem is not even mid. It's like Leetcode rate this problem as a medium. I would say this is a hard problem. You basically need to master the art of binary search patterns in order to solve this problem. And yeah, basically any two-dimensional array is a hard problem. This is my opinion. So you cannot take a two-dimensional array and put it as a medium problem. Yeah. So yeah, that's it for this video, and see you in the future.